Okay, so my definition of the mole now gives us a bunch of new conversion factors. Now, if you remember, we were doing conversion factors in Chapter 1, and we were using conversion factors for dimensional analysis. So what we were doing in dimensional analysis is we were multiplying the a number by a number that was equivalent to 1, not exactly equal to 1, but equivalent to 1, because the top number was the same as the bottom number. So we used conversion factors to make conversions like grams to kilograms, and then we used conversion factors to convert things like miles per hour to millimeters per second. And I also mentioned that you can use conversion factors to also convert things like liters of water to number of atoms of oxygen, of the element oxygen. Now, the conversion factors that I just gave you is going to result in you being able to do this kind of stuff. What we were doing in previous chapter, in Chapter 1, were stuff like this and stuff like this. But here, we're going to find new conversion factors that we're going to use for this. Something that you go from amounts of water, for instance, and resulting in number of atoms. Okay, so how are we going to get there? Okay, so what we said is from our previous definition of a mole, that 1 mole, and I'm abbreviating MOLE by using MOL. You can leave out the little e because it saves time, so we're going to leave it out. So that's my abbreviation for mole. So I can say 1 mole of carbon-12 atoms is equal to the Avogadro's number of carbon atoms and these would be carbon-12 atoms, and this is equal to 12.000, and this would continue to infinity because this is definition. So an infinite number of significant number of grams of carbon-12. And the reason why you have an infinite number of significant figures is because this is a definition. Okay, so we have this as a possible conversion factor. So you've got 1 mole of carbon atoms is equivalent to 6.022 times 10 to the 23rd atoms of carbon-12 is equal to 12 grams of carbon-12. So these are all equivalent, so you can use this as a conversion factor to go from moles of atoms to atoms of the element. Or you can go from 1 mole of carbon-12 to grams of carbon-12, or you can go from grams to number of atoms, and so on. So this is all a bunch of equivalents that you can use as a conversion factor. Okay, and you can do that for any element. Of course, if you use some element other than carbon-12, you're not going to have an infinite number of significant figures because it's not a definition. But we can choose any element in the periodic table. So let's look at our periodic table. So here's my little periodic table. And we're going to zoom in a bit. And okay. So we're going to zoom in and we're going to look at the periodic table. So here is our phosphorus. Okay, I'm going to blow that up so you can see the number. So the little block there says phosphorus, and on the top it says 15, and on the bottom it says 30.9, and it actually has a bunch of numbers, but I'm just going to go ahead and round that up to 30.97. Okay, so that's what my little block in the periodic table says. So here's my little block in the periodic table. So phosphorus, I have to zoom out. Okay, phosphorus 15, 30.97, and here's a little block in the periodic table. Okay, so if you remember, this is atomic number, and this is atomic mass. Okay, so from our definition that we got in our previous our previous definition right above, what we said is that one atom of phosphorus weighs 30.97 atomic mass units. So this is one atom equals 30.97 atomic mass units. We can also say the same definition that we had up here, so we can use this definition that we had up here. We can apply it for our phosphorus. So we can say for our phosphorus that 1 mole of phosphorus is equal to 6.022 times 10 to the 23rd atoms of phosphorus, the Avogadro's number of atoms, and that is also equal to 30.97 grams of phosphorus. So what you want to note here is that here our previous definition from our previous chapter was atoms to atomic mass units, and in this chapter moles to grams. Moles to grams. Okay, but we've got a conversion factor. Okay, so now we can do this for any element in the periodic table, so we can continue and look at another element. So let's actually look at another element in the periodic table. So the other element that we're going to look at now is our element. We'll just choose any old element we like, and we're going to choose our element calcium. Now let me just zoom in for a minute there so you can see it, although I don't think you can actually see the number. But here's our element calcium in the periodic table. So there's our calcium, and if I just rewrite it, it is 20, and then calcium, and on the bottom it says 40.078. It's got a little box around it. So that's what the little thing looks like. Oops, gotta zoom out. Okay, so that's what our little box says inside the periodic table. Okay, so I'm going to rewrite that over here. So my little periodic table for the element calcium is 20 and 40.078. So that's our little box in the periodic table. All right. So knowing what we know about phosphorus and our definition for the mole based on carbon-12, I can ask the same sort of question. So I can ask for 1 mole of calcium, how many grams of calcium do I have? I can also ask for 1 mole of calcium, how many atoms of calcium do I have? So that's a perfectly reasonable question that I can ask on the next quiz, and then you're going to fill in. So I would leave it blank like this. I give you a periodic table, and then you'd fill in the appropriate number into that little blank. So knowing our definition of the mole, we would say 1 mole of calcium is equal to, and we are going to give the answer 40.078 grams of calcium. And then 1 mole of calcium has how many atoms in it? It is 6.022 times 10 to the 23rd atoms of calcium. Now usually I give Avogadro's number somewhere on the piece of paper, so if you recognize Avogadro's number, then you'd be able to answer this question. Now what I often get instead of this answer right here, the 40.078 for the mass of calcium, what I often get is this instead. So instead of giving me that, what some people will give me is 20.0. 20.0. That's what some people give me. And what would I do if somebody gave me 20.0 instead of 40.78? They would lose full credit on this question because if you remember, this is atomic number, this is atomic mass, and a mole is equal to the atomic mass in grams, not the atomic number. So what we're looking for is the answer here is that. The atomic mass, the bottom part of the number that you see in the periodic table, the one that has the little decimal points, not the one that looks like a whole number. Okay, so that's a common mistake that everybody makes. So I know that you're not going to make this mistake on the next quiz that I give you because you recognize the difference. Okay, so then let me just stop for a minute here and continue in a later segment.